did fractions first is because most kids need to have an understanding of fractions before they do decimals. Okay? Because a decimal is really just another way of representing a fraction. Every decimal can be written as a fraction. Every terminating or repeating decimal can be written as a fraction. Okay? So one of the first things that we want kids to know is that when they see something like 1/10, they know that it can be written in this form or in this form, and those words are both, I use the same words to describe both of those symbolic representations, right? This is 1/10, and this is 1/10. Oh, just take both pages. So, when we're introducing decimals, we really depend on fractions. Okay? So this number, 1/10, represents 1 out of the 10 equal pieces I would need to make the whole. And if you think about place value, remember when we were learning about place value? Okay, just going to make a little place value chart here. Okay, 10 ones makes 1/10, right? If I'm using the base 10 blocks with little cubes, every time I get 10 little cubes, if I call that 1, then I can trade it for 1 10 rod, right? And every time I get 10 rods, I can trade that for 1 flat. And every time I get 10 flats, I can trade it for 1 big cube, and so on and so forth. Okay? Now, if I'm going the other way, okay, the same is true. So, 1 of these makes 10 of those. 1 of these makes 10 of those. If I cut 1 into 10 little pieces, each one of those represents 1/10. If I cut those into 10 little pieces, I'm taking 1/10 of 1/10, right? Multiplying fractions. If I have something that's 1/10 high by 1/10 wide, it's going to end up being 1 out of 100. Okay? So 1/10 of 1/10 is 1/100th. And 1/10 of 1/100th is 1/1000th, and so on. Okay? So when we're introducing decimals and place value and all that kind of stuff, we really need to connect back to our work with fractions. So the students need to see that this 1/10 and this 1/10 are written the same way. Okay? And that this can be called 1/100th, and this is 1/1000th. And these two numbers are said in the exact same way. They have the same name. And then it becomes easy to think about a fraction as a decimal or a decimal as a fraction. If I think about something like 25 over 100, that's 25 hundredths, but it can also be written as 0.25 because that's also 25 hundredths. Okay. So it's important that kids understand that decimals come from fractions, that it's breaking it into pieces. In fact, decimals haven't really been around that long. Okay. Fractions have been around much longer than decimals. In fact, the definition of a rational number was a number that you could make out of the ratio of 2 other numbers. Okay, by using 2 other numbers together. A rational number is another word we use for fraction. Okay, so anything that could be written A over B. So they said numbers are rational. Well, we call them now rational. The definition of a number really was anything that could be built out of the ratio of two other lengths, right? That's what the Greeks called it. So when they came up with numbers like pi, or the square root of 2, that couldn't be written that way. It literally rocked their world. And that is why they are called irrational. Because they are quite literally crazy numbers. Right? They're crazy. They don't work the way other numbers work. Right? So the decimals, in the sense of kind of figuring out how decimals work, is a fairly new concept in the history of mathematics. Fractions were much more commonly used. It was always about breaking it into parts. But we want kids to be able to model these things, so we often use base 10 blocks to do that. We'll also use a number line to do that. So kids should be able to use number lines and base 10 materials, and we're going to use decimal squares later, which you have on your tables as well. But they should be able to use those things to model decimals. Okay? But they really need to have that part of the whole thinking. Decimals are really a piece of something else. Just the same way fractions are a piece of something else, or part of a whole. Okay, so I can let whichever of these base 10 blocks I want to be 1. And everything else gets named dependent on what I call 1. Right? Just like with fractions. It depends on what 1 is. So you can't name those until I tell you what 1 is. So for today, we're going to let the big cube be 1 whole. Okay? So if that's 1 whole, because the flat is a 1/10 of that, or because I would need 10 flats to make 1, then this becomes 1/10, right? This becomes 1/100 because I would need 100 of them to make the whole, and the little cube will be 1/1000. Which I can not really grab. There we go. Okay, because I would need 1,000 of them to make this big cube, right? That's an important understanding for kids to have. They should have it before they start doing decimals that 1,000 of these makes 1 of these, right? 100 of these makes 1 of these. 10 of these makes 1 of these little rods. Okay? So you may need to revisit that when you're doing decimals in grade 4, 5, 6. Okay? A lot of kids have spent their whole lives calling this a 1, that a 10, that a 100, and that 1,000. Right? And now all of a sudden you're going to say, let's call this 1. It's really important when you're working in early elementary to not always say, you know, take out your 1s, take out your 10s. Like, call these little cubes and say things like, if the little cube is 1, how do we know the rod represents 10? Right? So that they realize that it's only called 10 because it's 10 of these little ones that we're calling 1. And why does the flat represent 100? Well, because it's equal to 100 of these little cubes that we're calling 1. Right? Because these things are only named relationally to what we call 1. And we often kind of set up these false conceptions for kids by only ever using them the same way, and we call them 1, 10, 100. And then kids be like, you called that 100 last week, and now you want me to call it a 10. Right? It's very disconcerting. So we do have to make sure we have flexibility with those numbers. So I'm going to set you to modeling a little bit. So you have some questions here. And I want you to just do the first couple of pages. So we're going to build some decimals. Okay? You can make sketches. We're going to use our knowledge of adding and subtracting to see if we can combine and separate decimals.